Hello everyone. As part of today's video, we're going to take a look at equations with variables on both sides. So the first thing we're going to go over today is exactly what to do throughout the course of this video. So some possible things you can be doing. Almost think of it as like the beginning or the first few minutes of a lesson, or the middle part of a lesson, I guess. Whereas I might put some steps up that you feel necessary to copy down. So you could take notes on anything you like. Obviously not this portion, but anything after this slide. So take notes. Just like they are in class, they might be highlighted or I'll indicate with some type of mark on what steps you could copy down. There's going to be various practice problems throughout this, two specifically. So at any point, if you want to pause it, obviously if you keep the video playing, you're going to see the solution and me explaining it. But if you want to pause it at some point to actually complete the problem, you could feel free to do that as well. So pause and complete a problem if you want to try it on your own. Maybe like after you see the first one, you want to try number 2 on your own, feel free. Complete questions on your own. Okay, and the third and final thing, obviously you could rewatch as much as you like. If you don't get something right away, the good thing about these videos, you can just rewind, rewatch from the beginning, go over a particular section that you didn't really click well with you. So you could rewatch. And the one thing that I will ask, I'll add this into number 3. After you're done, fill out in the comment section below. You'll see a little Google form, just as a little follow up on what you got out of this, what you still need help with tomorrow to better prepare me on what exactly we need to do tomorrow. So what that in is like 3A here. Fill out. I'm going to write G form, Google form below. Okay, so now that we've gone over what you should be doing during this, let's actually get started. So obviously from today's lesson, you can kind of guess what these equations are going to look like. Just like the title of the aim says, these have variables on both sides. When we say both sides, we're referring to the equal sign, the left-hand side and the right-hand side. Notice the variable here is t. We see it on both sides. So if you notice that picture in the title slide, which I'll scroll back to quickly, a lot of times with equations, we use that scale analogy of some type of unknown, balancing, that whole aspect. So when you have an equation with variables on both sides, think of this as a scale. Obviously, the equal sign is the middle point of our scale, and we have unknowns on both sides. Okay? So how I like to conceptualize solving this is if you have two unknowns, one on the left and one on the right, you probably want to get those unknowns together on one side rather than them being separated. You can clean up everything you want and move things around, but if you have something unknown on the left and something else unknown on the right, you're never exactly going to pinpoint what that thing is or what its value is. So I like to think of it in terms of grouping. We have numbers going on here, and we have variables, coefficients with variables. So I like to think of it as grouping numbers on one side and coefficients, or I should say, our variables on the other. And obviously, there's a first few moves we could do here. Before we start moving things around, we want to clean things up. So what do you think we can do first here? The correct answer would be to distribute. We wouldn't want to combine like terms yet. There are going to be like terms in a second, but we want to distribute first because there is multiplication taking place before we could start adding. So step 1 would look like this. After I distribute, I would get 16t minus 48. And I'm just going to copy down the right-hand side. Okay. Now on the left, I have 3t, I have 16t, so I can make this a bit more simply 19t. Okay, and now that everything's been cleaned up, we haven't really done anything new yet. We've done this in the past, simplifying and combining like terms. This is what I was explaining earlier with this whole analogy of unknowns on both sides. rather than them being separated on the left and right, let's try to group them. In other words, let's put the stuff we know, the regular numbers, on one side, and the stuff we don't know on the other side. We're kind of organizing them, if you will. And I'm going to choose to, we'll talk more about this later, but I'm going to choose to move the 14 over. So I'm grouping my variables on the left. There is some strategy with that, so it's just kind of random. And in the same move here, I could write my answer and do something else, but just to save some time, I'm going to move the 48 over to the right. Again, think of it like organizing. I'm putting numbers and variables. Numbers on the right, variables on the left. So obviously these will cancel. On the right, I'm left with 50. That's 2 plus 48. On the left, 19 minus 14 is 5t. And now, once you see that it is separated, it makes it that much easier to determine what that unknown was. So we went from having unknowns all over the place by separating or by organizing. Makes it pretty clear, one more move here to figure out what it is. In this case, we would divide by 5, and we'd ultimately get t equals 10. And as always, we can check this value by plugging in and verifying that it satisfies the equation. So, notes-wise, just to sum up what happened here, I noticed for step 1 it says if necessary. Not every equation will have distributing, combining like terms, so it's silly to say that's always going to occur. So if necessary, do that. Simplify, combine like terms, look for 1 or 2 moves you could do beforehand. Once you have it, usually you get to this stage, which I'll mark. Once you get to around this stage, I would say is pretty generic for these problems. You have a variable and a constant on the left and right together. This is where you really get into today's concept, which would be step 2, move variable terms to one side. So organize them on one side by adding or subtracting, obviously the inverse or whatever the sign is. And notice in parentheses, it's a good idea to move to the side with the bigger coefficient. It's not something that's required. It's not something that you're going to get wrong. We'll talk more about this tomorrow and maybe in the next problem as well, why this is a good idea or why this is suggested. Once again, it's not a requirement, but more of like, hey, this will make your life easier. And step 3, once you do that, you're going to have a 2-step equation basically, because then you're just moving the number over. And in our case, where we combined things up top in red there, we only had a 1-step equation because we added that plus 48 with that one move. Okay, and that's how we kind of go about solving these. It's all about organization, grouping, collecting things on one side, variables, and numbers on the other. So let's take a look at another problem. Okay, like I mentioned earlier, if you're feeling pretty comfortable and you want to pause at this point, you can pause, copy it down, try it on your own, and then watch the solution process. So, the only thing that's going to make this problem a little bit more difficult, we have, of course, our favorite fractions. I have no distributing, but I can combine like terms. I see 2 numbers on the left that I can combine. The one tricky thing, I want to get a common denominator. So I'm going to revision -2 as being -6 over 3. And this way I can more easily combine it with the 2/3. So these two would combine to give me -4/3. I still have the 1/5 x, so we see there's going to be some more fractions involved here, equals x minus 2/5. Okay, so now we want to we get to this stage where we have everything done and we want to get into grouping or organizing. I'm going to move my 1/5 x over to the right. Okay, on the right it was really, I want to put x there, that's really a 1x. So by moving the 1/5 over, we are moving to the larger side. Something that we'll discuss in more detail, and once again, not a requirement, but basically you're avoiding having to deal with negative signs and things get a little more confusing if you're just doing it randomly. Okay, so that's just going to give me 4/5. Okay, think of it as 1 as being 5. 5 over 5, subtracting 1 over 5 would give you 4 over 5. Now I'm going to move, since I moved my variables to the right, in the same thought, I'm going to move my constants to the left. And that's going to require a little arithmetic on the side here. We're going to do negative 4/3 plus 2/5. Okay, what common denominator should we get for 3 and 5? Probably 15 would be a good bet, which would be 20 over 15 and 6 over 15. And negative 20 plus 6, be careful, should be negative 14 over 15. Keep the denominator. Okay, this problem is a little sneaky with the fractions, because even at this stage we still have something, the one-step equation is not as easy as it can usually be. So now to get rid of the 4/5, what do I do when I have a fractional coefficient? You multiply by the reciprocal. Okay, anything times the reciprocal is 1, so these are going to cancel out. But now doing the same thing on the left, I do get some nice cancellations here. 5 goes into 15 3 times. 4 and 14 have a GCF of 2, so I can divide that out. And I'm going to be left with negative 7 over 6. And that will give me my answer. Okay, so now to zoom out a little bit, I can rewrite this if I want, negative 7 over 6, or negative 1 and 1/6. Okay, so that's applying the concepts that we discussed on the last slide to a little bit of a tougher problem with fractions. Tomorrow in class, we'll go over more detail with this lesson. We'll take a look at some applications, some word problem type approaches, and some fraction problems like this during the practice portion, where we're really applying some of those fractional skills that we've covered in the past with negatives, dividing, and multiplying, and adding, subtracting, so forth. Okay, so thank you for watching. Don't forget to fill out the Google form below if you have any questions, comments, or anything you'd like to share. And thank you guys for watching.